So,
Alice.
hi, Alex, can you hear me?
Yes, I can hear you well now. There's no echo.
Okay, great. Excellent, all sorted. Okay.
Except I think if you put it on presenter view, will people not be able to see it?
Yeah, no, it's just black.
I think you need to do the.
Oh, no,
no, it shows
Oh,
it.
it showed up. Okay.
Now, the next thing I'm worried about is I'll be able to play video smoothly.
Let's see.
Anyways, but let's see what happens. Okay, yeah. Without further ado, today's topic will be complexity, environment, and future aesthetics. Basically, that's part of what in the past few years I've been dealing with, and also the future directions. Okay. So as I said, I used to be a physicist. I did my PhD in physics, theoretical physics, and undergrad in physics as well. Then in 2010, around that time, I started to do creative artworks with methods I was trained with, and started off with light installations and etc., which I'll introduce more in details. So I returned to academia last year after 10 years of running my own studio. The studio is there, by the way, it's just run by someone else. Today, basically, I'll talk about two things in general. One is how science and art can intertwine by some example from art history leading up to this century. So maybe I'll talk about if we look at what I'm doing and what new media artists are doing and how it's related to the art history, especially in the 20th century. And the second part is I'll talk about our work and our ongoing work in the future. So specifically, I will talk about how contemporary art and how it's related to what we do, and some certain important, let's say, developments in art and technology, such as AI, cellular automata, cybernetics, cyborg, and also bioart. So just one slide to sum up all the artwork before the whole section. Yeah, and then we can all forget about them. So as you can see, I mean, the main point I want to bring up is that the art for the 20th century is mainly about, the art, if we talk about the first art where people draw in the caves of animals and sun, river, mountain stuff, it's to imitate nature and to try to imitate as real as possible, like Renaissance, we have very fine, detailed paintings and anatomy and stuff like that. So that's in the 20th century. However, in the 20th century, I marked out a few events that are that comes from other disciplines, such as politics, science, technology, biology, etc. And what new art came out of this period of time. For example, early 20th century, as most of you know, we have conceptual art, noise art. So the artist world, I'm sure most of you know very much in detail more than I do. So I'll just point out events that are connected to what we do now. So of course, I cannot talk about 20th century art without mentioning Duchamp. So he came out of the Dadaism in the early 20th century, and in his words, he wants to put art back in the service of the mind. And this work, Fountain, really allows artists to to use found objects. So it's then on we have installations, sculptures that are made by just found object, ready-made object. Whereas before 20th century artists, they make up their own painting from scratch, sculpture from just wooden blocks or stones. Yeah, and apart from art, in the field of music, there are also artists who try to, let's say, rebel and define the traditional, art, music should be in harmony and melody and, fitting the music theory and stuff like that. So this guy, Risolo, he's considered as the father of noise music or noise art, and he wrote this manifesto called Art of Noises. Basically, his idea is that since the Industrial Revolution, people live in urban environments with all the machinery, noises of man-made noises, factory noises, mechanics, and stuff like that. And these should become the elements for musical creation. And that's the main thing he stressed in his manifesto, Art of Noises. And he even went further to classify 6 kinds of noises. Noise exists everywhere, even before he was born. But really, if we talk about scientific discovery, being someone who came from a scientific background, maybe at first I didn't understand, why is it important in art, like doing something obvious, something exists already. But then I started to realize there's also a frontier in art. In science, you have the known, and the unknown, and there's a boundary. So every time you break the boundary, you make a discovery. You write a paper, and stuff like that. But art as well, there's a frontier of art. We think that frontier is what people accept as art, consider as art. Also, outside of that frontier is nonsense, trash, garbage. Okay, but it doesn't mean that garbage cannot become art. You need a theory to support why this is art. Then you are breaking the boundary. And for example, like Duchamp and Rousseau, what they did was to theorize and justify why they are doing it. And before then, nobody was doing it at least with a structured theory behind it. So, for example, if you look at Art of Noises, the 6 noises he classified, they don't really make that much sense from a scientific perspective. 6 categories. For example, one category might be, a puffing sound with air and breath, and one might be clashing sound, and one might be leaves, rubbing each other. But then, the distinction is somewhat vague. In science, we call they are not independent variables. They cannot be cleanly separated. Yeah, but anyways, in art, the act of classifying noises is something that has never been done. So that's why his work was important. And then we have the Second World War, where there were a lot of technological advances, computers, Turing machines, as you might have known. It was basically invented because the Allies wanted to decipher the codes by German Nazi. So, but then, and also atomic bomb, which went on to become, nuclear energy sources. So a lot of advancement was done during the war, before the war, and continue on adding up to the advance of computers. There was a discovery of cellular automata, which I'll talk about, and also the same time, in biology, the DNA structure was confirmed. And then in the 60s, video art came in, and Nanjun Back, by Nanjun, of course everyone is familiar with him. He basically, what he did was putting these televisions, traditional cathode ray tubes, to make sculpture. Of course, the reason I talk about the afternoon chunk is that he also used found objects, and more than that, he used found media content as well. He recorded footage of people and sound of people being edited and put it in these televisions. So not only found objects, but also found content. He's considered as the father of video art or media art. So, in parallel, a class of work called Generative Art or Design happened at the same time, which is based on computer technology. Generative art design usually refers to art that in whole or in part has been created by an autonomous system. Autonomous system doesn't really need to be computers or plugged. It could be unplugged as well. Like for example, biological system could be generative as well. As long as the creator or the artist himself is not really controlling this thing, this system, the whole time, then it's generated. Human intervention could come in at some point, but at least part of it is not controlled by human being. And this can be, of course, like computer-based AI data visualization, robots, biological system, materials like shape memory metals, etc., where the thing just evolves itself. Sounds, music sounds, yeah. And it really originated from cybernetics and systems theory, was pioneered by Nirvana and co-workers. Cybernetics is basically knowledge or theory about messagings, connecting parts of the system. For example, usually you have an input, and then you have the processing part, and you have output. A simple example of input would be like, so let's say, keyboard where you type text or recorder to record voices, and process computer that process these inputs and output would be like visual representation. And the pioneer of generative art, one of those pioneers was Georg Nies, a German computer scientist. He is in the 60s when computers become more and more mature, and it became sort of a consumer product. So he used these printers, which were originally used for scientific plotting graphs, to generate something in his words, meaningless or useless. Okay, it's first time not to do something technical with this machine, but rather something useless, geometrical patterns. And then he started to generate a series of artwork. He used, so he had different cells with a certain displacement from the center of the cell. And this displacement became more and more randomized as you go down. So he was interested in order and disorder, partly because sometimes we think disorder is similar that like emotion or being human is somewhat disorganized and random. So by having this contrast order and disorder, he was discussing whether computer can be more humane or human. So, well, you have it. And at around the same time, pioneers like Lillian Schwartz, American artist, who used to be a nurse in the Second World War. She even stationed in Japan for a few years. And then in late 60s, she collaborated with engineers and scientists from Bell Lab. She was also the first generative artist to be collected by MoMA. Just a very brief. Okay, seems like I can't press it. I think I can't use Google Meet while showing videos because yeah, but it crashed.
Oh, okay.
It happened before. Once before that, I'm told. So
You can try to share your entire screen.
yeah,
Yeah.
that's what I'm doing. Or in fact, the only thing is that if I don't use full screen, then it's fine. So I'll just have to share it like this.
You can see it now.
So for example, this graphic is generated from the lasers in the Bell Lab, which look like screensaver nowadays. There's really nothing we think special, or this is more interesting. Also optical works. And these are computer generated graphics. I mean, even though we don't think it's special now, but mind you, at that time, ordinary person was hard to. It's hard for an ordinary person to get hold of a computer. Let alone an artist. Okay. So yeah. So we talked about how artists use computer to generate arts. I would like to talk about Cellular Automata. It's again building on having this tool called computers. The mathematicians started to study things that could not be studied before the computer. It was a pioneer work was laid by John von Neumann, who worked at Los Alamos laboratory where they tested nuclear bombs, etc. This is Cellular Automata. I will not risk playing this, but basically, what we have is, say, like a chessboard, except one-dimensional chessboard, and then you have black, white. So it's like a game. They have rules, and this chessboard, the way it generates the next step is according to a certain set of rules. For example, the region circle, the highlight region, if it is black, black, white, then the next generation should be black, etc. should be black. So the system would generate the next generation based on these rules. This is called cellular automata. Maybe we'll play a little bit. Okay, a bit like this. So, yeah, that's how we generate an next generation. And then you can have different set of rules. You will see structures that exhibit certain patterns, even fractal patterns. These are called emergence. Emergence in philosophy, emergence in science, in art. Phenomenon that arises from connection between neighboring objects or people even. And even in nature there is such patterns. So cellular automata remain somewhat very academic exercise for mathematicians and computer scientists until in the 70s, the mathematician Conway, he invented a kind of a game he called Game of Life. He used 4 sets of rules that resembles underpopulation, overpopulation, reproduction, different kind of phenomenon that you will find in biological system or ecology. And then by using these 4 rules, this is what happened. In a 2-dimensional system, you have an initial configuration and then you just let it evolve. What it looked like is like a petri dish, like germs and fungi or what have you, life, organism evolving by itself. And you can generate very spectacular pattern from different kinds of initial configuration. I will not risk playing it, it will crash. But on the internet you can find out spectacular games of computation out of this set of rules. And nowadays, the artificial intelligence, where people use neural networks, it's highly related to cellular automata. Why? Because this is the structure of neural network. And the first layer, so neural networks they have multiple different layers, and each layer is like a generation of cellular automata, because the next layer is like the next generation, depends on the nearest neighbors of the previous layer. So there's a lot of similarity. So the works done by 60s, 70s really laid the groundwork for artificial intelligence. And from 70s, people, notably Howard Cohen, he worked with Feigenbaum at Stanford, who is an expert on artificial intelligence. So Howard Cohen started to create a system called ARM that would learn the style or painting ability skills from different people and start generating artwork of its own. Fast forwarding to a few years ago, a work produced by the French collective Obvious sold nearly $40,000 US dollars in Christie's auction. This painting is painted by an artificial intelligence that was trained on of around 15,000 Renaissance paintings, and generated completely new painting on its own. And on the signature side, the artist group put on an equation that is used in their algorithm of generation. So it really raised a lot of questions as to what art is, what artist is. Some people think art should be done by people because it needs a human touch. But if you look at it, you cannot tell if it's done by a computer or human hands. And if you say our work is defined by whether it sells or not, it sells a lot, right? So from all kinds of perspective, it seems like AI can be artists. Then another question is, will machines replace human artists? This is some food for thought. Cyborg. What is cyborg? Cyborg is basically building on cybernetics and combining with organism. In fact, in the 50s, 60s, when Norbert Wiener pioneered cybernetics and system theory, he was a genius to recognize that machines can be viewed as exchange of informations between parts, right? Then he also went on, in fact, in this book, Human Use of Few Human Beings, he said organisms, life itself, can be viewed also as a system. We have a brain sending message to the hand to move, and we have skin to sense heat and transferring the message to the brain to notify danger, and then we react. So it's the same as a machine. Then he argued that then we can connect, why don't we connect machine and organisms just by another type of exchange of information? So then artists, authors, in the literature, novelists started to create this imaginative being called cyborg. That's a combined word of cybernetics and organism. A very famous artist who does this kind of work is Stellar. He used extended robotic arms and also like spider-like machines, and even implanted an ear in his own arm to discuss how to augment human body and how to expand human ability, and also question consciousness. What is consciousness? If consciousness, if you change your body parts and the location of them, would you still be you? Would I still be the same person if I change my body parts? It raises a interesting question. So I'm going to show a video. And first I have to jump. Ugly, right? And also not practical. Artists like this kind of stuff. Yeah. And in the late 20th century, we have the rise of bioart. One of the pioneers, Susan Anker, she really came from a sort of traditionally trained art background, so you can sense from his work it's referring to a lot of art history. For example, well, she put a lot of sort of objects, living objects in petri dish, objects that resembles life and death. And she was referring to this series of work to a style of painting called vanitas, which also plays like a skeleton and angel wings and stuff like that to also talk about life and death and putting them together. She also used, for example, MNR scan of brain and using 3D printers to print the shadow parts, which look like some maybe butterfly or bats, etc. And if you look at the studio of Susan Anker, it really deviated largely away from what normally people perceive as artist studio. It really just looked like a biological lab. That really also showed how art became diverse in the second half of 20th century. And fast forwarding to now, we really use a whole range of hybrid materials. Just some very brief example. Olafur Eliasson, a Danish Icelandic artist, he used a lot of inspiration or material from nature. And in 2013, he did a work called the Weather Project in Tate, which simply used 200 something of monochromic lamp and put it near the ceiling, and with some mirrors hanging from the ceiling, he was able to form a gigantic sun or sun-like object that made it's very captivating. And also, he created a foggy chamber, which I actually experienced in 2019 at Tate. It's a 90-meter long corridor, and you just enter it, and your visibility is 1.5 meters. So it really shuts down your vision, and you have to find your way through just maybe sixth sense or something other than your visual. So a very interesting experience. He also used moss in galleries. And also, artists now became more aware of the surrounding and what's happening in society, environment, etc. So, for example, in 2014, he shipped around 20 huge ice blocks from outside of Norway, and then transporting them to city Copenhagen. Each of these blocks weighs from 1 ton to 1.5 tons, so it's very, very heavy, and he just let it melt in the city. He does that for raising awareness of climate change and global warming. So during the course of 1 month, 2 months, people just see the ice blocks melt. And it's very interesting because nowadays, with this type of work, you can decide how you want to interact with the artwork. So I always find like children, they have their own way of playing with artwork, because we do a lot of interactive work, and when the children comes, they always do something else. So I was quite interested. Then I became less and less. I don't really, let's say, plan how the audience will interact with the work as much. And artists, for example, Chris Wood, you use this dichromic lenses. These lenses are usually used in optical labs, and she made very spectacular work out of it. Another work I like very much by a Swiss artist, Lam. He used sets of polarizers. By turning them, overlapping them, he was able to create a very spectacular moving pattern that never repeat itself. Right. So let me introduce what I have done in the past 10 or 11 years. I founded our collective called Legacy Lab International, Chinese 人语, by combining art, science, design, engineering together. And we did a lot of new media art installations, performance, interactive work, and immersive experience. The first work we did was called Light Form. This work is interactive with wind, so the light moves in the direction of the wind. We have wind sensors to pick up the wind from the environment. It was in 2012, 10 years ago exactly. At that time, people don't talk about 科技艺术 or tech art a lot. Like most people have never heard of it. Some people have heard of digital art, but their concept of digital art is more like animation, computer graphics, and stuff like that. So at that time, because my background, I had training in programming, being a theoretical physicist, and program every day. So I started to use program to control machines, lights, motors, etc. And also, light is the most basic element of visual art, right? So it was, at that time, in light festivals, there are still just traditional lantern, okay? But now, as you can see, from all these light festivals and events, it really became a mainstream. Okay? So, but 10 years ago, it's very rarely seen this kind of work. And fast forward to 2017, in the first few years we did a lot of light work, light art, installations, landscape art. And the interesting thing with art that requires technology or technical elements, we had to manage our technology or our creativity. It has to be well documented because the assistants or our members come and go. You cannot restart every time with someone new comes in or someone leaves. So we have to manage these techniques very carefully. And then in 2017, I think that's when the light art became was at a high peak, so to say. We go from two-dimensional light installations to three-dimensional. We use these light bulbs and put it in audience seats of a theater, and we did a series of performance in Huaxiang Meiju. So the audience really sits and surrounded by these light bulbs where we can control the content. And so our musician, performers, and dancer, they can really interact with these light installation. And the installation became an extension of their body and an extension of their music instruments. It's a very fun project to do. For generating these light contents, we had to develop our own program for editing these interactive works. Because basically in show business, well, it's there are some restrictions. For example, you have only, let's say, 1 week or 2 weeks of performance, and then you will have 4 days of setting up and rehearse. You cannot program your content on the spot, so you have to do it before. So we generated our own program where we can arrange our light bulbs in all kind of 3D configuration and edit it, and then at the spot we will transfer these codes to our machines and they will play, hopefully. So this work, because it's the first time when people put these light bulbs into audience C, so receive some international coverage. So around 2016, we started also to look at what other materials we can use apart from light. And we started to use fluid. And in this world, we use water and generate bubbles in these tubes with light, so it synchronizes with the light. As we can see, we also played with the optical properties of the light tubes. So we can bend light, so to speak, around in space and arrange in complex configurations. So from now on, we look more closely in the fluid material just by using them without light. And we created a series called Water City. The reason it's called city because it's to refer to the architectural form of these works, and the movement of the fluids could be metaphor for energy flowing in this urban environment or traffic, informations, etc. And that work you just saw is now in permanent exhibition at Imperial College in London. Good thing about playing with medium and trying to control them is that once you succeed, you can change your configuration, color, and etc. It became a whole new work. We spent 3 years doing researching, developing this technique. So in past 3 or 4 years, we started also to look more closely and try to connect with some, let's say, contemporary issues like environmental issues, health issues, etc. And there's a series of work related to what I call doomsday aesthetics, 末日美学. So it's really related to the concept of Anthropocene. Some of you might have actually researched on that maybe. The word Anthropocene is proposed by a Nobel chemist, Nobel winner, Paul Crutzen in 2000, because he did a lot of research on atmospheric compositions. So he knew that there are a lot of carbon dioxide and other like radioactive elements that comes out of human activity, let's say nuclear bomb testing or agriculture or factory and manufacturing and so on. So his concept is that the current epoch called Holocene that has been around for 10,000 years should end and a new kind of epoch should begin called Anthropocene. And the reason it's called Anthropocene is that this epoch should be defined by human beings, because in fact, if you look into the geological layers, these byproducts by human activities can be found significantly in these geological layers, so much that they define a geological epoch. You know, it's something very significant. You know, before then it is like you have like dinosaur bones or fossil fuels and etc. You know, insects, birds. But now you can find maybe like rubbish or something else. For example, nuclear waste, or because they release these nuclear elements into the air, and in the end they drop to the ground. So since his proposal, really artists also, and not just artists, designers, and environmentalists and scientists, etc., became aware that this is a serious problem. This work we did in 2019 was exhibited in Baozhang Wangjie, the Treasure Hill Light Art Festival. This work is called Nirvana. Do you know what Nirvana is? Nirvana is basically like the state of nothingness, state of selflessness, state of peace that all Buddhists strive for through their lifetime of, 修行，真好，修行，practice of Buddhism. So if we consider our pursuit of technology as the practice for Buddhism, then what will the Nirvana be like for us? So that's the narrative behind this work. And we constructed this indoor landscape, basically a waterfall out of consumer waste products, and along with these fluorescent dye, even electronic boards and so on. What we did was a very, making mountains waterfall. It's a very classic Chinese artistic practice. But what you see is a mountain of waste. So it's really, you can look at it on either side. Is it ugly or is it beautiful? And on one hand, it is made from rubbish, but then it looks vibrant. And the way it's vibrant looks like it doesn't look very healthy, right? So it's this work it's like maybe a prediction of future or a warning, whether which way you look at it, depending on which way you look at it. So this is really along the concept that I think we should accept we are living with these waste, and in the future these waste will not be 100% gone. We have to co-live with it. We will be surrounded by these, images, landscape that are polluted, or plantations that are not so green, and even human beings, like obesity is a product of fast food industry. It's happening. It's changing our outlook, our appearance. So we are saying one thing we are thinking is that if this, what we consider as ill-looking or polluted or unhealthy look, will be the foundation of future aesthetics. Like this is beauty in 30 or 40 years. I mean, it sounded like a bold statement, but if you think about our industrial style or loft style, 工业风, 50 years ago, we cannot imagine it being something beautiful, right? We want to cover the pipes and cables with, wooden planks and etc. But now we just want to see it. So it's, if you think about it, any appearance that lacks if we human are adjusted to whether it is sound, whether it is visual appearance for long enough that it represents an era, then there's a possibility for it to become aesthetics or aesthetic elements. This is similar to what Rousseau talked about noise art. So what we did was we looked for the appearance of polluted or doomsday appearance. We use this 硫酸铜 so copper sulfate. Yay. So copper is one of the most common pollution that we find in water stream, in river streams. And so we use copper sulfate to poison the plant and look for the state where it lives, but lives unhealthily. And then we use this kind of configuration to do an insulation. And let me. Okay. Let me just jump to what we are doing in our new lab, Future Narratives Lab at NYCU now. Is that we are using deep learning to learn the style of, for example, rubbish, the style of polluted water, and also rust. And then we would synthesize any given image with these style images to produce, for example, architecture with style of rubbish or wasted water or rust. These are very preliminary results, so there are some parts that doesn't quite make sense. For example, the sky with plastic bottles and so on. But that's the idea. And now we are trying to understand this technology we use, this AI, this deep learning neural network, whether we can control the style to make it do what we wish. We also use other materials like, for example, thermochromic paint, where we really we start to experiment with thermochromic paints and make painting that changes color according to temperature, and we control the temperature of our canvas, so we can make a predictive pattern. And I would like to further make note that different people look at this work, give total different interpretations. For example, some people look at it and they think they see ripples on the lake, or some people think they see eclipse. Some people think they see life coming out of like mother's womb, etc. So I mean, it's interesting using these natural materials to produce artwork, because the behavior of the natural material consists of some unpredictedness, and you control it, but you can never control 100%. Not like you control computer programs. And these uncontrollability really they somehow triggers people's past experience and memory. For example, if you think it looked like, let's say, solar eclipse, or say it looked like a sunset, then you might remember how it felt like at that moment, the person you were with, and then that brings together to become the experience of viewing artwork. It's a bit like the work of 4 minutes 33 seconds of John Cage, where the whole piece completely silence, but not really silence because all the echo in the room and the noise in the room, and even to go further, your emotion due on the day becomes part of the song. So it's really an element of indeterminacy in viewing these kind of artworks. So this work is called Energy of Things. The title of the work refers to the energy of materials and how we find a way to visualize it, even the movement of the energy, which is basically heat. But we don't say what story it tells, what you should experience. We completely leave this to the decision of the viewers. In 2020, we did this work, and it's now being collected by National Taiwan University. So in the campus, you can see this work. This is Yushan Jade. We used the open data from NASA and did some processing of the data. Just to show you, this is really Mount Jade. Like if I ask you, Yushan 看起来这样子, how does Yushan look like? Normally people in their head comes out Mount Fuji. Yeah, it's not like Fuji. But no one ever could tell me what Yushan really looks like. So just to prove to you that what we are printing is Yushan. What we did was this series is called Flying Mountains. We used 3D printer to print out a very large part of Yushan to about 2.5 meters wide, with some light insulation behind to resemble the moving clouds. See if you look from above. To show a little bit of the process, for 2 months straight, we had 5 3D printers in our studio, printing non-stop. And then we had 125 pieces of these blocks that we have to put together. That's not the worst part. The worst part is sanding this and making the surface smooth. Fortunately, I wasn't the one who did it. So this is a student from Shijian University in the graduate school of industrial design. We used to be an engineering student in Tsinghua Dashi. So the member, just to mention, the member of our studio really comes from a diverse background. Some had come from 美术班, so like art class in high school, and then studied electrical engineering, and then for graduate school they went to Taipei Fine Art University to study theater, something like that. So diverse things. So our current and future work. Since last year I came to NYCU, I set up this lab called Future Narratives Lab. What it is we combine experimentation with narratives. So for experimentation, we combine technology, design, aesthetics, and to generate new media out of the experimentation. And on the narrative side, we storytell nature, humanity, environment, and society. We combine the issues and concepts from these disciplines, and then to generate new content. We use really a variety of media, and also the nature of our work, and it has elements of a lot of things. For example, speculative design, interactive design, digital manufacture, sound art, generative art, AI, VR, and AR, etc. So really, before then, like when I set up Legacy Lab International 10 years ago, I was introduced ourselves as new media artists. Now I'm bringing forward a concept of non-media. Basically, by saying non-media, we mean we don't see the media. Media is not our main objective. Our objective is the story behind it. It's also, maybe has a taste of Taoism, okay, Wu. So, in Taoism, people say Wu. By saying Wu, nothingness, void, what he really means is Yo, which means, it's all non-media, but actually we use everything that is necessary to tell the story. Okay, so the first, we have three main directions at the moment. One direction is art in the Anthropocene, which I just told you about, and the second is Audible Complexity. Basically, everything we see has an element of complex system and theory in it. It describes society, it describes nature, it describes politics, it describes how commodity is treated in marketing theory, etc. So complexity exists every level of our society, and we use different kind of new media to realize we want to experience that the viewer be able to experience by sound or by visual effects. And also we wanted to provoke discussion, critical thinking through these experiences. This is a work we did 1 or 2 years ago, just before coming to NYCU. So it's really, this project will be a continuation of this project. This work is called the rice pile model. Basically, we use grains. The grains could be, for example, what you see here is pill, because in this work we talk about antimicrobial resistance issues. Like if you throw away antibiotics, then it pollutes the environment. You generate the so-called superbugs, and the superbugs kills. So let me just pause. So if you say if you get a cut and you get infected by these superbugs, then you die. There's no antibiotics that cures this kind of infection, or you can get a cold, then you die because there's no pill that can cure you. At the moment, there are 40,000 people dying from this kind of symptom in US alone, and it became an emerging issue defined by the United Nations, and they predicted in 2050 100,000 people, 10 million people would die from this symptom, and that will surpass the people dying from cancer, so to speak. So this is also for this work is to raise the awareness of this problem. What we did was we generate this slope, and once the slope is formed, if you put more grains on it, it generates avalanche. And we have a camera that picks up the movement of these avalanche, and then we translate these movement into sound, digital sound, and this digital can be anything. Can be what you hear is maybe not loud enough. Is like a clashing of noises. So what you see is very small miniature, but what you hear is completely opposite. So by giving this contradicting experience to the viewers, they will wonder what the story is behind it. These pills are real pills collected from just general public. So by collecting, asking for donation, we also disseminate this information about the problem of antimicrobial resistance issue. So it's really it's a project, it's not just an hour, it's a project of raising awareness, actually doing the artwork, and also promoting it, promoting the knowledge. What was unexpected was we had to package these pills. We spent the assistant spent a lot of time, hours and hours in packaging. What we are doing now is using more complex models in complex science, models that were used for studying earthquakes. We will generate more works that can be experienced. So this is the second direction. Third direction is on quantum aesthetics. Actually, I'm about to finish.
You sure? Because when it appears, it will die immediately. I tried it before. It's quite embarrassing.
Yeah, I think so. I have another video which I want to show.
If the pound coin suits yours.
No. It's okay. Okay. So quantum aesthetics really comes the motivation behind doing quantum aesthetics partly because quantum physics is something just really counterintuitive. And for example, you have talk about like Schrodinger's cat, parallel universe, that concepts that are becoming more and more mainstream nowadays through movies, TV shows, etc. Or sci-fi novels. And on the other side, quantum computing is becoming more and more mature, and they predicted that in 7 years, quantum computers could really enter into our lives. This graph just shows you how qubits. Well, in classical computer we have bits like 0 and 1, 0 and 1. In quantum computers they have qubits, and it's been really, really difficult to scale up the number of qubits. But now it's going up exponentially, so we really are almost having a real usable quantum computer. And this is the actual what it looked like. Now, Google and IBM all invest a lot of money and Microsoft in developing it. So in this project, basically what we will be looking at is from the physics side, we want to do visualization and sonification for an easy understanding of what it is to the general public, and also discuss what the worldview is like, the philosophy behind it. On the other side, by actually using equations in quantum physics. So it's like going back to my pastime interest or passion. We know how to calculate wave equation, wave function from these mathematical formula. So what we get is the actual quantum thing. And by looking at this quantum thing, we want to in contrast to the traditional way of doing quantum art is to draw an atom and talk about an atom, and was doing a sculpture that looked like an atom. We actually use quantum physics to generate data, look at the data. On the quantum computer side, it has algorithm, and we'll be discussing emergent properties from the algorithm, and also discuss how future would be like through some maybe speculative design, etc. So this is just because this it's only started, and our goal is basically to offer intuitive understanding and digging deep into the quantum world and also imagining the future. Some possible representation. Just to show you work done by an Australian artist called Paul Thomas. He read an article by Richard Feynman. Richard Feynman is a very famous physicist who proposed quantum computing in the 80s. And he was reading this passage, and the voice was transferred, recorded, and transferred into data. The data is fed into a quantum system of electrons. And this is a graphical representation of what the data look like. The blue line is his voice, his reading. And the green line is the response from the electron. So you name this artwork talking to an electron, because this is effectively what he did. So there are many different, imaginative way of doing these things, and now our job is to imagine it. For example, a program, the algorithm could be visualized in different ways, etc. And wave functions can be experienced by different means. So with that, I